Hi students, this is Mr. Eckert. We're going to go through part one of Target E4, which says you should be able to explain the concepts of gene flow, speciation, mutations, genetic drift, and sexual selection as they apply to evolution using real-world examples. So we talked about natural selection in the first two targets. We went over the four principles of it, which I'm sure you can remember. If you don't remember them, you need to go back and review those. But there's something that sounds similar to natural selection. It works in a similar way, but that's artificial selection. So how are the two similar? Well, they both involve something that's selecting a particular trait in an organism, and in both cases, certain traits are going to give the organism an advantage in that particular situation. But in natural selection, it's of course nature or the environment that's doing the selecting. So if we have a population of, let's say, deer in Ohio, usually nature is going to select for the deer that are maybe a little bit faster because they're going to be able to outrun coyotes that might be a predator of those deer. So we think of selection in that sense. In artificial selection, something besides nature, and almost always it's humans, is doing the selecting for the particular traits. So it works in similar ways because a trait is selected. I'll give you an example. Think of all the different kinds of varieties of cows or horses or chickens, for example. Excuse me. So those different types were selected by humans. So humans wanted a horse that was all white and had dark spots, so they bred horses until they got that variety, and they called them Appaloosas, for example. You've seen chickens with big showy feathers, others that have shorter feathers. So all those traits were being selected for by humans, and they bred until they got those particular traits. That's artificial selection. Here's an example of natural selection using a rainforest. There's lots of shade in a rainforest, so if you have a population of beetles that lives underneath the trees, there's going to be, because of genetic variation, there's going to be some beetles that are just maybe a little bit lighter colored than other dark beetles. So the ones that are darker are of course going to blend in better. They're going to be more camouflaged, and the lighter ones are probably going to be picked off by predators. So those dark beetles are going to be selected for. They're going to survive, reproduce, and pass that trait on to their offspring. Artificial selection, you probably maybe were aware of this, but if you go back in history long enough, there really wasn't all the kinds of varieties of dogs that we have today. It was pretty much a dog that looked very much like a wolf. And as people domesticated those, and then decided, well, you know, it's pretty cool having this wolf-like dog around, but I'd like to have something that looks a little different. So they then started breeding dogs to look and be the kinds of varieties that we have today, everywhere from Chihuahua to Great Dane to German Shepherd. So those were all bred to look that way by people, and that's artificial selection. Gene flow is simply a movement of genes from one population to another. Now, how does that relate to evolution? Well, a movement of genes from one population to another would introduce genetic variation, and that, of course, is very important in terms of evolution. So the word migration is there. That reminds you of animals or organisms moving from one place to another. In this case, it's genes moving from one population to another. Now, that can happen a number of different ways. It shows here pollen can just be picked up and blown by wind to a new destination, and that can introduce gene flow. Organisms themselves, like birds, can be blown, especially like if there's a hurricane. They can be blown perhaps to different islands and introduce new genes into a different population. People moving from one place to another, a new city or a new country, would certainly be another example of gene flow. So here we see a diagram that's demonstrating that. Perhaps you have two different populations of beetles, green and light brown, Maybe they were separated by, let's say, a river that prevented them from interacting with each other, and through a severe drought over perhaps even a couple of years, the river dries up, and now the beetles are able to interact with each other and breed, and that would represent gene flow. So because beforehand they were not able to reproduce and intermix, and now with the elimination of the river they were. All living things that reproduce sexually, of course, have variations. There's genetic variation, which produce variations in their traits. A variation is simply just a difference, as it says, in a population of organisms. So if we're looking at a group of penguins, we wanted to measure their fat or how much blubber they had, you would expect that they would not all have the same amount of blubber. So that would be an example of a variation. A variation isn't an adaptation until or unless that variation gives the organism an advantage in its environment. So once it becomes an advantage, then it's considered an adaptation. So all living things that reproduce sexually have variations. Not all of those variations are adaptations. So again, going back to our penguin example, if it gets even colder in their environment, then having a little bit more blubber would be obviously an advantage, and help those penguins to survive better. So within one organism, can you have changes in variations? Well, no, because those variations were determined by the organism's DNA, and the DNA is not going to change. So they're stuck with those traits, those variations, until they die. But how about within a population? Well, again, because of things like sexual reproduction, mutations, crossing over, independent assortment of alleles, you've got genetic variation, and that can produce then new variations in a population of living things. Adaptation within one organism, I want you to be very careful about what this is saying. Don't misinterpret it. It says, yes, you can have a change in an adaptation within an organism, but notice what's changing. It says if the environment changes, then a variation that used to be harmful to the organism might now be an advantage, and vice versa. So let's go back to those penguins, those that had, let's say, less blubber. That was harmful to them in a cold environment, but if the climate is warming, now that's a change in the environment, so that variation that used to be a harmful variation, having less blubber, now is an advantage. So notice that the trait itself is not changing, it's the environment that changes. That's an important distinction. So here's another example. If you've got some grasshoppers, and within the population there's mostly green grasshoppers, but there's some brown mixed in there, and they live in a green prairie. Obviously the brown ones are going to stick out a little more. Maybe predators are going to pick them off more easily. But again, let's say there's a drought, a severe drought, and the prairie dries up and turns brown. Well, now the green coloration is no longer going to be an adaptation because it's going to be a disadvantage. They're going to stick out and be eaten by predators. The browns would now be an advantage. So again, note that the environment is what changes, not the trait within the organism. So we're going to stop there. This is kind of a little bit longer of a target. This will be the end of part 1, and we'll pick up part 2 on the next section.